Welcome back to the video, guys. In this video, we'll be starting with activity 2.4, which is based on the echelon form, and we'll see the first three questions. So let's get started. The first question says that A is a matrix where the first row denotes the topmost row, and the ordering of rows in the order from top to bottom. Among the given set of options, identify the correct statements. The first non-zero element in the first row is 3. So it is wrong. We can see the first non-zero element here is 1. The first non-zero element in the second row is 1. So yes, here we can see the first non-zero element in the second row is 1. There is a non-zero element in the third row. So no, there is no non-zero element in the third row. And the fourth option says, since there is a row with all elements as 0, the determinant of A is equal to 0. So yes, since the R3 is 0, the determinant of the matrix is 0 as well. So option number 2 and 4 are correct. Now let's move on to the next questions. So the next two questions are based on this common data. Here the data says that I3 denotes the matrix, identity matrix of order 3, and S is defined as the set of all these matrices. Now, what do we have to do with these matrices? So let's check question number 2. If S1 is the subset of S consisting all the matrices of S such that they are in row echelon form, then choose the correct options. So we have to select the matrices which are in the row echelon form. Now, how to identify whether a matrix is in REF form or not? So if it satisfies these three properties, then we say it is in row echelon form. The first is all non-zero rows are above any rows of all zeros. So if I have a row like 0, 0, 0, and then I have a row like 0, 0, 1, then it is not in row echelon form. If there is a all zero row, so it should be in the bottom. Now, coming to the property 2, that says each leading non-zero entry of a row is in a column to the right of the leading non-zero entry of the row above it. So for example, I had this row where I had this leading entry here, 0, 1, 0. So then in the next row, the leading entry should be in the right of the leading entry of the previous row. That means I cannot have my 1 over here, I cannot have my 1 over here. If it is in the row echelon form, then the 1 has to be here. Okay, so these two ones cannot be there. Okay, now there is one more property over here which is not mentioned, that is each leading entry must be 1. It is for our syllabus. Each leading entry, which is called pivot also, must be 1. Must be 1. Now, option number 3 says all entries in a column below a leading non-entry are zeros. So this we have seen as well, that all the entries in a column below a non-zero entry are zeros. That means if I have a leading entry over here, 1, and let's say there was some 2, 3. So all the entries below this one, which is my first leading entry, must be 0. Okay, so once we know this much information about the REF form, now let's jump onto the question and let's try to identify the matrices which are in REF form. So this matrix is not in REF form. Why? Because here this is my first leading entry. The second leading entry is here, but it says that the leading entry must be right to the leading entry which was there in the previous row. Okay, so this does not satisfy the property number 2. Hence, it is not in the REF form. Talking about this, so here the leading entry is -1, which is not 1. So it is not correct. Here the leading entry is 1. Then for the next row, the leading entry is 1. And the next row is a 0 row. It satisfies all the condition. Hence, C is in the row echelon form. Now D. Here a 0 matrix is also in a row echelon form. Now E. So E has the first leading entry as 1, but the second leading entry is not to the right of this leading entry. So hence it is not in REF form. Then coming to F. So here is my first leading entry, here is my second leading entry, and here is my third leading entry. All the entities below the leading entry are 0. So hence this is also correct. Here also I have my first leading entry as 1, and in the second row the leading entry is 1 as well. So this is also correct. This is also in REF form, but this one is not in REF form. Why? Because here I have -1, which is not allowed. This one is also in REF form, so it is also correct. An identity matrix is just 1 1 1 0 0 0 0 0 0. So it is also correct. And then it is 1 1. So it is also correct. So here, if I talk about the matrices which are in REF form, so the matrices are C, D, then F, then G, then H, then J, then K, then L. Do we have an option like this? C, D, F, G, H, J, K, L. C, D, F, G, H, J, K, L. Yes, this option is correct. And the cardinality means the number of elements in the set. So here we have 1, 2, 3, 4, 5, 6, 7, 8 elements in the set. So cardinality of S1 is 8. Moving on to the question number 3 that talks about the reduced row echelon form. So how do we know whether a matrix is in RREF, that is reduced row echelon form, or not? So for that we have this definition that a matrix which is in RREF form must satisfy all these properties. So what are these properties? Let's change the color first. First, it must be in REF form, that is row echelon form. Then the leading, that is the non-zero entry in each row is 1, and each leading one is the only non-zero entry in its column. Okay, so these three uh, properties must be satisfied. Now let's check about C. See, 1 and A and B are not in REF form. So first property is not satisfied. So we'll only check for the matrices which are in REF form. That is starting with C. So here C, uh, 1 is there and all the other entries are 0. Yes, 1 is there. All the entries below to it and above to it are also 0. So it is in RREF. This is also in RREF. This is not in RREF because the entry above the leading entry 1 is not 0. Here, this is also not in RREF form. Why? Because the entry above the pivot is non-zero. So it is not in RREF, it is not in RREF. It is in RREF, uh, it is also in RREF, it is also in RREF, and it is also in RREF. So we have CD, RREF, we have C, D, then H, then J, then K, then L. C, D, H, J, K, L. So C, D, H, J, K, L. And the cardinality here is 1, 2, 3, 4, 5, 6. So this was all about the first three questions of the activity 2.4. We'll see you in the next video. Till then, bye.